Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today we are going to discuss SRAM memory cell by using MOS transistor. Last class we discussed about DRAM, dynamic random access memory, and today how it will be designed, right? A 3 transistor memory cell, 1 transistor memory cell. So every time it is a capacitor charge storage, right? We can refresh every time, but it is SRAM, static random access memory, right? It is a memory cell, SRAM. Let's see this one. So it is a static random access memory, right? Random access memory. Okay, so anyone will ask in the examination. So it is a static random access memory, right? It is a memory cell which stores the data. Okay, it is a memory cell. It is a memory cell store bit data, store bit data, right? So it is store bit data, store bit data, less capacity than DRAM. So it is we can say it is a low power. It is low power and less density memory, less density memory chip, less density memory chip, right? So it is a faster, it is faster than it is faster than it is faster than DRAM, right? When we data usage, the memory space, so whatever we are storing the data, it will be faster than the DRAM and less space occupies, right? It is one of the memory of the RAM, static RAM, right? Let us see different types of static RAMs. Today we are going to discuss different types of static RAMs. SRAMs are classified into different types. SRAMs are classified into, today we are going to discuss, let us see, mostly asked question in external examination, 6 transistor SRAM, 6 transistor SRAM, right? It will be ask you 6 transistor SRAM, right? 6 transistor SRAM, and the second one is NMOS pseudo NMOS pseudo static RAM, SRAM, static. It is designed by NMOS. Okay, static RAM, random access memory. And the third one, let us discuss CMOS pseudo static RAM, right? This is the third one of classification types of SRAM, right? It is less power and cost also. It is high cost design than the DRAM. And one more thing, it is high cost, right? High cost design than the DRAM. High cost design than DRAM. Right, we can say this is a differences. We can also take this as a differences between SRAM and DRAM. Right, high cost, faster than DRAM, low power and density, less density, and memory cell stores the data. Right. So let us see the first one. The first one is 6 transistor memory cell. So it is 6 transistor memory cell. There is 6 transistors are there. NMOS pseudo static RAM and CMOS pseudo static RAM. Let us see the first one. First one is in examination it will be asked 6 transistor SRAM. Okay, 6 transistor SRAM. Let us see the working of 6 transistor. Working of 6 transistor SRAM working. 6 transistor SRAM working. Right, how it will be designed by MOS transistors. Right, it is designed by data storage by using MOS transistors, NMOS or PMOS, like. Okay, so let us see the first one. Let us see this one. Yeah, here we can take the NMOS transistor. You can see this one. Right, this is what here connected. Let me see this one. It is how it will be designed. Right, you see this one. Okay, now here the back-to-back inverters are here. The back-to-back inverters are connected. NMOS and PMOS back-to-back inverters. One output as a input to the another inverter. The back-to-back inverters. This is a supply voltage, which we can take a VDD. Supply voltage VDD. Okay, this is VDD ma. Okay, and after this, so from here to here we can connect one transistor. Okay, one transistor is a complemented transistor. Complemented transistor. Right, we can connect here from here to here. Okay, and from here to then this inverter. So from here to we can connect to this another inverter. Right, so let us see this one. This one is a CMOS inverter, back-to-back inverter. The above one is PMOS, below one is NMOS, above one is PMOS, below one is NMOS. Right, above one is PMOS and NMOS. Here we are applying the bit data. Here we are applying bit data. Right, let me this one. So it is a gate. Gate terminal is here. Okay, let us see this one. The gate terminal is connected over here. Okay, bit and bit complement. The complemented is applied over here. Bit and the complement is taken here. So this is WL word line. Okay, WL word line, row line. Okay, word line. We call it is word line. Right. Let us take the transistors. Think we need to take bit complement. Okay. Now let's take this transistor T1, transistor T2, transistor T3, transistor T4. Right, so how many transistors are here? 6 transistors. So back to back 2 inverters, 1 2 3 4 and 5 and 6. Let us take this one as a transistor T5 and transistor T6. Right, it is completely designed by 6 transistors. 6 transistors. The data stored 1 bit and the complemented bit. Okay, complemented bit is stored here. Right, so here it is a connection. It is a connection. right? From here to here it is a connection. Now let us see the, so data is applied. So whenever the word line is high, whenever the word line is high, then this T5 transistor is on, and also the T6 transistor is also on. So whatever the bit data is applied, then the complemented is taken. The complemented is taken, which is passing through this one, passing through source and drain, right? We can say it is source and drain. It is source and drain terminal. So this one is a gate terminal, gate of the transistor, gate of the transistor. So when gate voltage is high, when word line is equal to high, it will be 1. Then what happens? Then this will be on. T6 is on, T5 will be on. Now bit is 1, bit complemented is 0. Now bit is 1, it is passing through source and drain, which is connected to the T4 transistor. Now T4 transistor, 1 means T4 transistor is on. Now 0 is passing through source and drain, which will be connected to this one, this inverter. So in this, the T1 PMOS transistor is on. So this is on, and this is on. For 1 it is T4 is on. For 0 T1 is on, right? So it is stored 1 bit data. It is a write operation. Bit is a input. If this is a path to input and this is a path to input, bit and bit complemented are on, then the data will be stored in this T1 and T4, T1 and T4. Now if the same data is, input and output, so this is a input, we can apply here input and output, input and output, right? Input and output. So read write operation, we can say input and output, right? Input and output. So input means we can take it is a write operation. Input is write operation, this is write operation. Output is read out, write into this memory cell, write into these transistors stored in memory cell, MOS transistors, and read RD, read out the same path, read out from the same path, right? So any memory location we can write into the memory cell, we can read out from the same memory location, right? We can read out from the same memory location. Okay, if you see, this is a ground terminal, because it's a supply is connected, and the ground terminal, right? Let us see the working operations. Now when write operation is equal to 1, when write into the memory cell, write operation is equal to 1, word line high, word line selection, right? Word line selection, word line high, then what happens? Then T5 is on, transistor, then complemented up. So it is T5 is a bit, so T5 is a bit transistor, and T6 also on, this is a bit complemented. So the bit complemented, okay. Then after, what happens here? So when word line is high, write operation we are applying to this bit line. Now what happens? Transistor T5 is on, transistor T6 is on. It is a bit and bit complemented, both are on. Now the data passing through this one we are applying, then bit complement is 0. Now bit, it is passing through this one, bit is passing through, one bit is passing through this one. Now T4 is on, for bit, and for bit complement T1 is on, right? Now, so what happens? For bit is equal to 1, transistor T4 on, transistor T4 on, okay. Now bit complement. Now what is a bit complement? If you are taking the data binary, right? It is a 0, 0 we are connected. So bit is 1, bit complement is 0. Now transistor, what is that? T1 bit complement means 0, 0 is applied. For 0 logic is applied, T1 is on, it stores in T1, it stores in T1, T1 is on, T1 is on and store, T1 is on and store, T4 is on and store, T4 is on and store logic 0. Now bit complement is stored in T1, bit is stored in T4, right? This is a write operation. This is a write operation through, write operation through. So write operation through bit and bit complement. Write operation through bit and bit complement, line, right? Bit complemented line. Transistor we can write in transistor T5 and T6, T5 and T6 T5 and T6, right? Now the another one, right into the memory cell through the bit complement, 1 bit data is stored. Now the second one is when read operation is equal to 1, we are read out the data which is stored, we can read out the data which is stored. What happens then? Read operation is equal to 1, whatever the stored data which will be read out the same path through bit and bit complement. So read operation is equal to 1, data stored in T4 and T1, and which will taken to which will taken through same path, the same path whatever it is, right? The same path it will be, which will be taken through same path. So that is bit and bit complement, bit complemented path, bit complemented path. So if word line, when word line is high, then it will be stored T4 and T1, word line is high, this is a high line, it is for the transistor on and off. Okay, word line is high, now what happened? T5 T6 is on, the data passing through bit and bit complemented, so it is act as a bit and bit complemented, act as a input and output line. Right into the memory cell, right in the memory cell. If bit is equal to 1, bit complement is 0. Now bit is equal to 1 which is passing through, then the path established from here to here, from source to drain, the path is passing through and which will be connected to the T4. So T4 is on, which holds the 1 bit data. T4 is on, which hold 1 bit data, which hold data, 1 bit data, bit complement is 0, it is passing through source and drain, and T1 is on, hold 1 bit data here, right? So write and read, two operations is performed, right? Right? When RD is equal to 1, it is passing data stored in T4 and T1, so which will taken to the same path, bit and bit complemented, right? The another one is if you take hold the data, when third one is when bit line or word line when word line is low, then what happens? Word line low, then then bit complemented off, bit complemented transistors are off, bit complemented transistors off, bit complement transistors off. Now what happens? Then the data is hold, then the data is hold, then the data then the data hold in T4 and T1, T4 and T1. So this is what happening, this is what happening. So hold, read operation and write operation, three operations are performed, right? So when write operation is equal to 1, then the data will be right into this, T4 and T1. Now read operation is equal to 1, the data will be same, it will be whatever the stored here, then it will be passing through same bit and bit complemented line, now the word line, when word line is equal to 0, what happens? So T5 and T6 are off, then whatever the data is hold in this T4 and T1, so which we can do the two operations. So one is write operation, read operation, and holding the data, right? Hold the data, right? Write operation, read operation. Now let me tell you this one. So the last point I want to tell you, write operation and read operation, write and read operations, write and read operations, when word line high, okay, when word line high, then bit complemented, we can do write and read operation, bit complemented, bit complemented transistors, bit complemented transistors can perform write and read operation. So line is high, word line is high, through, can write here, through bit complemented transistors, through bit complemented transistors, right? So word line is equal to high, then the transistors are bit complemented transistors are on, then word read write operation, write and read operation through bit and bit complemented transistors, right? Through bit and bit complemented transistors. Now hold the data. Second one is hold data. When it will be hold the data? Hold data when word line is low. When word line is low, what happens? When word line is low, the data will be hold. So bit and bit complement transistors are on. So through bit complement transistors are on, we can say, right? So bit complemented transistors are off. Bit complemented transistors off, bit complemented transistors off, which hold the data, right? What is the write operation? Which hold the data. So this may be happened. So after writing, then it hold when both transistors are off. So read write operations when word line is high, it is through the bit and bit complement transistors. Both transistors are on, right? So this is about working of 6 transistor SRAM memory cell, right? Now let us see the another one. Second one is NMOS pseudo static RAM. Pseudo static RAM. So it is designed by pseudo NMOS transistor design. Okay, it is the inverter is designed by pseudo NMOS inverter. Pseudo NMOS inverter. So it will be like this. It will be like this. Let us see this one. The designing of a transistor. SRAM designing by pseudo NMOS transistor. Pseudo NMOS transistor. Right here. Here is a internal is a inverter. The two inverters are there. Cascading connection. Right here. Only it is we are discussing about only 1-bit data. So there is a millions of transistors for data storage. Right? It is by MOS transistors. Each transistors hold 1-bit data. So millions of transistors. That is a IC fabrication. Right? Now let us see this one. So this is an inverter. Right? It is inverter 1, inverter 2. Now it is a clock signal. Clock signal. We can say it is a write operation. And this we can take a read operation. Okay, write operation and read operation. So it is a bus. It is a bus. Data stored 1-bit data. Bus, we can say it is a 1-bit data store. Right, 1-bit data store. 1-bit data store. Right, let us see this one. The working of, let me tell you this. When write operation is equal to 1, when write operation is equal to 1, write operation is equal to 1. Now what happens? Let us take transistor T1, transistor T2, right, transistor T3. So it is designed by 1:1. Length and width is 1:1. Here also 1:1. Here also this designed by length and width is 1:1. Right, it is not 4 by 1. So when 4 by 1, 1 by 1, it is in inverter. Right, inverter to inverter, it is connected to 4 by 1, 1 by 1. So it is 1 by 1 ratio. The design of this transistor in a storing write operation, that is 1 by 1 length and width ratio. Length and width ratio. Length of the channel, width of the polysilicon. Length and width ratio. Right, WR. Okay, it is write operation is equal to 1. Transistor T1 is on. Right, transistor T1 is on. You can see this one. Transistor T1 is on. Now what happens? Data from the bus, it will be passing through the source and drain. Now inverter 1. Now it will be 1. Then output of this one is 1. And output of inverter is 1. Second inverter. This is first inverter and second inverter. So inverter 1, it is passing through these T3 transistors. Right? It is passing through T3 transistors. Again it will fed back. So clock is always on. So clock is on as long as the clock is on, then the data will be passing through this one. So clock is on, T3 is on, clock is high. Okay, clock is on, it is clock is on. Now whenever the clock is high, so clock is high, we can say it is high. Now what happened? T3 is on. From inverter 2, the data is passing through this one. Again it will be stored. The 1-bit data is stored over here. 1-bit data is stored over here. So whenever write operation is equal to 0, then clock is off. Now clock is off. What happens here? The data on this inverter 2, it will be again replaced onto the bus. Again it will be replaced onto the bus. Right? This is what happened in pseudo NMOS inverter. Right? The inverters are pseudo NMOS inverter. So let me tell you here, the pseudo inverter is like this one. The pseudo inverter is, so the pull up is a PMOS transistor, is a ground connected, right? And this one is a NMOS transistor. This one is a NMOS transistor. So VDD, this is VDD, right? VSS, VDD, VSS, and input and output. Input and output. So it is a PMOS transistor. PMOS is on transistor. PMOS is ground connected. So PMOS is on transistor. In inverter NMOS, replacing the depletion mode transistor, and placing with the PMOS transistor, and this is NMOS transistor. So the complete, it is a pseudo NMOS inverter. Pseudo NMOS inverter replacing the depletion with PMOS, the ground connection, VSS, ground connection. So it is always on transistor. When Vin is equal to 1, let me tell you this: Vin is equal to 1, output is 0. Now Vin is equal to 1 means it is 1 means it is on. It is connected to ground potential. Then output is 0. When Vin is equal to 0, open circuit, output is equal to 1. It acts as an inverter. So this is called NMOS pseudo inverter. Pseudo inverter. Pseudo inverter. Right? It is a NMOS pseudo inverter replacing depletion and placing a PMOS transistor. Right? So let us see the working. Then first one. Now what happens when WR is equal to right operation is equal to 1? Right operation is equal to 1. So right operation is equal to 1. Clock is high. Now clock high. Then high clock. Now what happens? Transistor T1 and transistor T3 on. Transistor T1 and T1 is on, and T2 also, T3 also on, T3 on, and RD is equal to 0. RD is equal to 0. So data on the bus, it is stored in data on the bus, on the bus, data on the bus passing through, passing through, passing through. What happens? Passing through T1 transistor, passing through T1, stored in inverter, stored in inverters, stored in inverters. The inverter pseudo NMOS inverter, inverters, right? Stored in inverters, stored in inverters, right? Whenever the second one is when read operation is equal to 1, WR is equal to 0, clock is low, clock is low, clock is low. What happens? T1 is off, T1 is off, T3 is off, right? T3 is off, T2 is on, T2 is on. Then the data return back to the bus. Data stored in inverters. Data stored in inverters return back to the data stored in inverters. Data stored in inverters. Inverters return back to the bus. Return back to the bus. Return back to the bus. So it is write operation and read operation. Write operation and read operation through the inverters. Right, inverters. Write operation is equal to 1. This is off. The data on the bus, it is passing through source and drain. It is 1. Complement is 0. 0 complement is 1. Clock is equal to high. It will be again, it is stored over here. When RD is equal to 1. When RD is equal to, before it is 0. When RD is equal to 1. Now write operation is equal to 0. This is off. This is off. Now what happens? The path is established. So the one inverter 2, then data will be again replaced onto the bus. This is what happened now. Now the third one. Now the third one is CMOS, 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 CMOS pseudo SRAM. Right? It is a 1-bit data store again. So instead of the data input is applied to input is data we are applying, only write and read operation is equal to 1. But whereas in this CMOS we can apply the complemented, right? We can apply logic, any one logic, right? 0 or 1, 0 or 1 which will be on, 0 or 1 it will be on, right? Same thing, but replacing the T1 and T2 and T3 by this pass transistors. It is a what we call transmission gate. Transmission gate. right? So it will be on for any logic we can give. Any logic we can give, whether it will be 0 or 1 ma, whether it will be 0 or 1, right? Let me tell you this one. So this is a PMOS, PMOS and NMOS, designed by PMOS and NMOS. So designed by PMOS and NMOS. This is a inverter 1, inverter 2, right? Let me write here. So this is a bus line, 1 bit data stored, 1 bit line, 1 bit store data, temporary storage data, 1 bit data storage. So WR is equal to 1. So it is WR complement. WR complement. We may give 0 or 1. 0 or 1. Inverter 1, inverter 2. So WR complement, it is a clock. Okay. What we call it is a clock. So clock complement, we are applying clock. Anything we can give. 0 or 1 which will be on. So previously it will be only it will be 0, it will be 1 only, then it will be on. Previously it will be 1, then only it will be on. For this transistor, it may be applied 0 or 1. For any logic we can give. For any logic, 0 or 1. So it is 0 and this is 1 ma. So any logic we can give. Any logic we can give. Right? So what happens? Same will be operation. Any logic we can apply. Write operation may be input is 1 or 0. 1 or 0. Read operation also 1 or 0. 1 or 0 we can apply. So this is what happened. Right? This is what happened in this. Let us see and we close this. So first one when WR is equal to 1 or WR complement is equal to 0. Any one we can give. Any one we can give. Any one logic we can give. Any one logic we can give. Then what happens? It stores data. It stores data in inverters. It stores data in inverters. Right? So as long as clock, we are applying. Okay. Right. So now when RD is equal to 0 or 1, we are applying any one we can apply. RD is equal to 0, RD is equal to 1, or RD complement is equal to 0. So any logic we can apply. Read on data will be replaced onto the bus. Replace onto the bus. Only 1 bit data. It stores in the inverters. Replace onto the bus. So this is what happening. So this is what happening. So the inverter is we are using here. We are using it is CMOS pseudo SRAM. So it will be designed by write read operation by CMOS. WR and read transistors are CMOS complementary transistors. So it is 1 we are applying, 0 it will be on. Any logic when apply. But previously it is only write operation is equal to 1 it will be on. Read operation is equal to 1 it will be on. 0 it will be off. 0 it will be off. But we can in this we can take here write operation is equal to 1 or 0. Read operation is equal to 1 or 0. So data stored here. So 1 is stored here, it will be 0 and complement. So it will be any one will be applied, any logic we may apply, then data will be stored, and any one will be applied, then again data will be replaced onto the bus. So this is what happening in SRAM. 1 bit data storage, 6 transistor memory cell, NMOS pseudo SRAM, CMOS pseudo SRAM. This may be asked in examinations. Okay, thank you. Please subscribe our channel, inform to your friends. Okay, thank you, ma.